Okay, I'm back for part two. Sorry, I only have a 15-minute time limit on these. So noble gases, as I mentioned, very stable, very unreactive. When you they glow though when electricity is passed through them. So if you see a neon sign in a storefront and the different colors, the red color, the red lettering would be neon going through a gas tube. If it's a bluish or purple, that might be argon uh, in that glass tube. And when you flick the switch and electricity goes through the gas, it creates these neat colors. We're going to move in one row here to this row here. These are our halogens, and they are group 7. They are all non-metals. Now, this family here, they don't look the same as each other. They are the most reactive, and reactivity decreases as you go down the group. But they don't look the same because fluorine and chlorine here are at room temperature 20 degrees Celsius. They are gases. Then we have bromine at room temperature. It is a liquid. I think I might have misspoke earlier and said chlorine. It's not. Bromine and mercury are the only two elements that are liquid at room temperature. And then iodine and acetine, they are solids at room temperature. So definitely not looking the same, but they all act the same. They are very reactive. They are kind of the equivalent on the metal side to the alkali metals. So these are the most reactive non-metals. And this family is also known for being good at killing viruses and bacteria, and quite often used as ingredients in disinfectants. So chlorine here, we put that in our pools, in our hot tubs, bromine as well, pools, hot tubs. Not usually in pools. It's more expensive than chlorine, but definitely in hot tubs. It's a little bit more stable too. So when you could use it in small amounts of water like a hot tub, where you're not going through a lot of it, it actually lasts longer so you don't have to use as much. Iodine here used in the medical profession. You can put it on, they would use it for prepping for surgery. They would put iodine on the skin around where they're going to do the incision to make sure there's no virus or bacteria that can go into the incision and uh, cause an infection. Perhaps you've used iodine at home for the same reason. You've got a cut and you've put some on it to disinfect it. Now, I did mention that reactivity decreases as you go down. So going back to our periodic table here, on the metal side, things get more reactive as you go down. On the non-metal side, they get more reactive as they go up. So on the non-metal side, up at the top here, these are the most reactive of their respective families. On the non-metal or on the metal side, these are the most reactive with respect to their families. Also, as you move in toward the center of the periodic table, things become less reactive. So on the metal side here, the alkalis are the most reactive, followed by the alkaline, and then into the transition metals. So things become less reactive as you move inwards. Same thing on the nonmetal side. So the halogens, family 7 here, are the most reactive, and we become less reactive as you move inwards. And of course, with the notable exception of our noble gases here, which are not reactive at all. History of the periodic table. So Mendeleev was the first to arrange these elements, and he arranged them by atomic mass. Going back to our periodic table here. So what he started to do with the elements he had, and at the time he was doing this, he did not have all these elements, but he would arrange them. Atomic mass is this number down here. So hydrogen, I think, is, I can't read it, just going off memory, 1.01 or something. Helium is it's 4 point something. Lithium is 5 point something. Beryllium is 6 point something. I can't remember. But he did them in order. So helium has, or sorry, hydrogen has the least mass. It weighs the least. Then helium, then lithium, then beryllium, then boron, carbon, nitrogen, oxygen, fluorine, neon. So he put them all in order. And so he had this big, huge row of all these elements. But then he noticed that some of the characteristics are the same. So what he did was he sort of took this big long row of elements and he started to reorganize them. So he did hydrogen, then helium, and then he's like, well, wait, instead of putting beryllium here, it acts just like hydrogen. So he put it underneath. And then came beryllium and all these, and eventually got to neon, which acts the same as helium. So he made sure that was underneath helium. And rather than putting sodium out here, he realized that it acted like hydrogen and lithium, so he put it underneath again. And so as we do have all these elements are in order going across the rows in order of weight, but he's also stacked those rows on top of each other so we get these columns. So kind of cool how all these elements are in order of weight, but then the rows, only 18 rows that the row starts over, and elements with similar family properties, the way they act, are stacked on top of each other. At the time too, different elements would be missing. So maybe, let's just say that he didn't know about aluminum. So that would have been a blank. And maybe he didn't know about chlorine. So that would have been a blank. And eventually, as these elements were discovered, they fit into those blanks by their weight and by the way they act. So if you didn't know about chlorine, and that one was just left a blank because sulfur would have been in the oxygen family and argon would have been in the noble gas family. So that would have been left a blank. When it was found, it's kind of neat how it fits in there, not only in terms of its weight is between that of sulfur and argon, but it fits in the family perfectly as well. So as elements have been discovered, they have fit back in. And now we have a full periodic table of elements. These ones up here will never be filled in. They can't, because there's nothing with a weight in between. Any new elements we found have been added in down at the bottom, and you can see some of these weird ones down here, and there's actually more that have been found. Most of these have been found in a laboratory setting, so not out in nature. Scientists have been able to take a compound, break it into its pieces, and as they've broken it down into their basic pieces, their basic Lego, so to speak, they've found these ones. And some of these, they don't last very long. They're very reactive, and so they might only last a split second in a laboratory setting before they are part of a compound again. So Mendeleev was credited with coming up with the periodic table. He, as I mentioned, he arranged them in terms of their increasing mass or weight. When an element seemed to repeat the properties he'd already seen, he started a new row, and this resulted in elements with similar properties being arranged in vertical columns. If he didn't have an element that fit that space, he left a space for newly discovered elements to fit in later. And his periodic law states that if elements are arranged according to their mass, that similar patterns will occur regularly. And we, of course, know that to be true. We are only 18 rows across here, and then it repeats again. 18 rows across, and it repeats. And so we do have a pattern there as well. All right, a bit of a long explanation here, but I wanted you to start to get a full or a more fuller understanding of the periodic table. So that is it for today. Have a great day, everyone.